And with that, I would like to invite our next speaker, Mr. Alan Wang from Carrier. He's the CO2 sales manager for industrial refrigeration sector. So Alan, please join us. Hello there. How are you doing today?
Good, good. Hey, how about you?
Excellent, very good. Now we have went fairly smoothly through the event, so we are looking forward to your presentation and your take on another solution that can be applied in industrial refrigeration, food cold chain sector, and that is CO2 Transcritical. So please start your presentation.
Okay, thanks, Xiang. Yep. So hello, good afternoon, everybody. This is Alan from Carrier. It's my great pleasure to present the CO2 Transcritical system application in cold chain and the food process market. Okay, we come to the second page, which is the HFC phase-out plan. So here, I would like to echo the importance of the environment-friendly refrigerant application or refrigerant business. So since we have been seeing the massive kind of upcoming renewable of the refrigerant in our business, so this is very important for our kind of application in this area. So next page, please. So this one shows why CO2 is being selected as a refrigerant. So basically, we have four kind of the good candidate of the CO2 as refrigerant. The first one is it's environment-friendly refrigerant. So the GWP equals to 1 and the OTP equals to 0. So which is has no impact to your environment. And the second one is most important is safety of the refrigerant. So actually for CO2, it's being classified as grade 1, A1, which is non-toxic and non-flammable refrigerant. So it's pretty safe for the residential and the commercial application, okay? So come to the third and the fourth one, which is the same as CO2 has a very high efficient and cost-effective compared to the other refrigerant like ammonia and or the HFC for the R44A or 410A, which has the good heat transfer performance especially at a low ambient temperature. Low temperature application. So that is the most effective for CO2 as a natural refrigerant. Okay, next page, please. Carrier has been a global kind of HVAC and R player in the market to CO2 tech. So actually, we have about 4 technology. We have the CO2 cascade system applied to introduce it to the market. This is the most common technology we are using so far. We are using the CO2 as low side of the refrigerant and use high side, we are using ammonia or HFC. This is targeted to the application or climate application for the system. Coming to the next 2004 and 2014 and 2016, we introduced the pure CO2 transcritical system into a market. And we have the different iterations of the CO2 transcritical booster system, which has a limited application range. It's only focused on the mild and the cold climate, which has a very lower ambient temperature in the domain, in the range. But coming to the 2014 and 2016, we introduced 2 very big or climate product into a market, which is the CO2 transcritical with ejectors. This can be applied to all the domains through the warm climate, the mild climate, and the cold climate. So this is our technology journey to the CO2 system. Okay. So next page, please. This one shows the CO2 solutions for the warm climate. So actually, we aim to introduce CO2 for all climate, and the warm climate always is being the barrier to the technology because of the high pressure of the CO2 of the ambient temperature. Okay, so we have the different scenario or technology to address this high ambient temperature lead to the high pressure of the system, including mechanical subcooling, the parallel compression, or the modulating vapor ejector, which is being patented by Carrier to leverage or to greaten the system performance. This is the CO2 solution for warm climate. Okay, next page, please. This one is most likely the CO2 product marketing segment for Carrier. Actually, so far, till to now, we have about 18,000 products sold in globally, and it's by the data we have, we have over 50% of the market sharing in the market, and within the data we collect, 75% are transcritical CO2 system requirement from the market. So this is a very significant kind of trend of the CO2 technology applied in the market. So transcritical is the next phase. Okay, next page, please. This one shows Carrier CO2 product portfolio. We have the different product to address the different application needs, from the store expansion to the industry application. So we have from the minimum cooling capacity of the 3 kilowatts to the biggest one so far is 1,500 kilowatts for the industry application. So this is a complete solution to cover the different customer needs and applications requirement. Okay, next page, please. So come to the biggest one, which is cover or align with our topic today. So industry application. So our biggest industrial CO2 product is a power cooler. This is the biggest one so far we have in the market. So actually we introduced the biggest 6 cylinders compressor, which is close to 100 cubic meters power for the swept volume for each compressor. And all the control logic, all the key component design, like the receiver in the system, is Carrier design based. So this is a product we introduced to the market, and it's very high efficient, which is I'm going to introduce for next page, please. This is the product range for the power cooler. So actually we have 4 versions of the product. For a single evaporating temperature for the media temperature, which is for the cold room. And we have the single evaporator for the lower temperature, which is the freezing room. It's close to minus 32. The lowest temperature is minus 40 or 45. And also we have the dual evaporating temperature for the media temperature and the lower temperature. The first version I'm not highlighting here is for the secondary cooling. So we have the chiller version for the air conditioning, which used to use a secondary heat exchanger for the air conditioning application. For the applications range, so here we have the heat pump, we have the logistics center, we have a sport venue, and we have the ice rink, snow arena, and the food processing also for the supermarket and hypermarket. This is application range for the power cooler. Next page, please. Being a high efficient product for CO2 transcritical product, so we have 2 major enablers to make sure this is a high efficient. The first one is Carrier patent modulating vapor ejector. This is the one we used to increase the system performance by uplifting the compressor suction pressure. So we are using the high pressure gas from the gas cooler, in some words, is condenser, to uplift the suction gas for the consumer. In that scenario, the inlet suction pressure of the compressor can be uplifted about 3 to 6 bar, which is to reduce the compressor power input. So this is the very simple logic. And based on the experiment data we have from field and the test data, the energy efficient improvement for this modulating ejector combined with the semi-flooded evaporator, the energy efficiency can increase about 17%. Here I take Shanghai, for example. This is from China. But if we are using consider about the Southeast Asia country like Philippines or the Singapore, Malaysia, the ambient temperature is much higher, then we can gain more heat efficiency improvement. If, for example, if the ambient temperature is 30 degree, then the total energy efficiency improvement can up to 20%. So that is much significant energy saving for a big industry application. Okay, so that's his first one, high efficient product enabler. Next page, please. The second one is the heat recovery. So CO2 system compared to the conventional refrigerant like ammonia or the HFC system, the heat recovery, the CO2 can provide a multiple temperature layer of the heat recovery from low temperature to the high temperature. And also the heat recovery amount is much more than the ammonia or the HFC system. So here we have did a very simple calculation. So we increased a little bit the power input to uplift the complete discharge pressure to get more heat recovery from the system. Then the total heat recovery of the COP, consider the heat recovery, is up to 5. And also if we consider only about the cooling, the COP can be 2 or 2.2, 2.3. Now we say heat recovery can up to 5. This is a very, very big improvement of if we consider a scenario of the both heating and cooling requirements simultaneously. Okay. So this is the second enabler of the power cool product, which is a significant heat recovery provider. Okay. So next page, please. Next one is I'm going to go through the case study. So we have 4 cases to demonstrate the CO2 transcritical product application. The first one is the large distribution center in Finland. So this is a country-wide, country-sized logistics center. So the total refrigerant area is about 30,000 square meters, and the total height is 22. So this is very big, and it covers the cold area, the frozen area, and the blast freezing area within the 2 racks of the around 3,000 kilowatts for the cooling capacity. Next page, please. This is some of the technology we are using. So first one, this area is the ammonia is not is constrained to use is this area, and in the meanwhile we're using a big spring water tank as energy buffer to store the energy for the heating in the winter and also the subcooling in the summertime. Okay, and also considering the heat recovery system, so we designed the heat network within the CO2 product, the heat recovery, so to gain the biggest benefit from the system, and also considering the system EER below the 10 degree, actually the CO2 has much more significant benefit compared to the ammonia system. Okay, next page, please. So this one is the kind of some of the benefit we gain from or the case study from Finland distribution center. So the electricity using from the system here is by the natural resource, the wind and the water. So the emission of CO2 is negative. So compared to the ammonia or the HF system, the CO2 emission is much less or even negative. And also for an energy cost, if we compare it to the conventional refrigerant system, the energy cost about 20% saving, within a similar size of logistics center, and also within the demand of the load shaving at peak usage. If we will count or done count for this side, the total energy cost reduction is about nearly 70%. So this is very attractive to the customer. And also, as a result, we get a very kind of the positive feedback from the customer, which is they highly recognize the system and recognize the solution. Okay. Next page, please. The second case is another logistics center in Spain. Here, we list here is to demonstrate the warm climate application for CO2 transcritical. So in this case, is close to the South Europe in Spain, Valencia. The maximum ambient temperature in the summertime is close to 43 degrees. It's pretty hot. And while the system is running smoothly, so we can make sure the system is run safe and smoothly. And of course, we can gain some of the benefit for the modular ejector operation. Since the temperature is high, and we can gain more pressure left by the modulating vapor ejector. So this is the second case for the Spain. Next page, please. Next case is another case study for the food processing industry. This is one facility in China. So we are counting the comparisons between the ammonia system and the CO2 transcritical. This is pretty similar for the cooling capacity of the two units. And we count for about 1 month operation for the both system. You can see the chart here. In August, this is the most hot season in China. And these two facilities are running in sequence because they have different duty. And we count the operating time, the hours, and we have the energy power to account for the total electricity consumption. So based on the timing, the data we collected from the field, the total energy saving for the CO2 system is about 8% saving than ammonia system. And please bear in mind, this system has no ejector. So if we have the ejector equipment in the CO2 system, then definitely we can get more the energy saving compared to ammonia system. As I just mentioned, the ejector can uplift to about 17% of the energy saving. So for this case, if we are using the ejector, then of course the energy saving for this system is much higher. We would imagine maybe a 15% or even 20%. So this is the case study for the food processing industry. This is third case. Next page, please. The first case is another case study, which is a little bit irrelevant for the industry code room. This is also for the CO2 transcritical application. This is for the China National Speed Skating Over. So actually, this is over built for the Beijing 2022 Winter Olympic Game. So this is the ice rink for the speed over. So actually the ice surface is around 12,000 square meters, which is the largest in Asia domain so far. And this have a 400 meter speed skating track, and also have the two ice rink, about 1,800 square meters for the two ice rink. Also, this is the first CO2 transcritical technology for direct cooling applied in Olympic Games. So we have some of the CO2 applied in the South Korea, Foshan, or the Sochi in Russia, but this is first transcritical CO2 technology application for the Olympic Games. And the total project size about 36 kilowatt for the cooling capacity, and we equipping about 6 CO2 rack, and for 600 per each for the cooling capacity, and the CO2 total charge is 43 tonnage for the system. Okay. Next page, please. This is a simulation of the system impact by unit CO2. Actually, we simulated the annual energy consumption of the CO2 system compared with the HFC. So the CO2 system has about 28% of the energy saving by the whole year operation of the system. And it saves about 2 million kilowatts electricity for the whole year. If we count for the household consumption, it's about 6,000 urban household in Beijing for 1 month's consumption. So this is a little bit kind of significant of the energy saving. And also for the environment side, for the carbon emission, so we actually for this case, there's no, or the carbon emission is close to zero. And by the impact of the system, we have about, the carbon emission equals to about 4,000 vehicles emission per year for the carbon, and equals to plant 1.2 million trees for the environment. So for this case, it's both for the energy and also for the carbon emission. The benefit is very significant. Okay. Next page, please. This is a quick guidance of the heat recovery application for this case. As I just mentioned, the CO2 system has a very good heat recovery, cover the different temperature range and a very big amount of the heat capacity. So this is exactly the application of the heat recovery in this case. So we have the lower temperature range of the anti-frost heating for the ice rink, which is for the 15 degree. And for the middle temperature is about 30 degree for the ice pour melting to melted ice. For the high temperature range, the 85 degree for the water is for the hot water, and for the ice resurfacing and the dehumidification. So that's it for the high side of the application. So this is very big variety of the heat recovery application for CO2 system. Okay. So that is I know the time is very short, and this is a quick, the guidance of the CO2 transcritical application for the cold chain and the food processing application. So long story short, CO2 is a good refrigerant, and it's deserved for us to explore in the future. Okay, that's my sharing.
Alan,
thanks.
Alan, thank you very much. Very informative presentation. We have time for a couple questions, so please stay with us. We have a question from the audience, and the question is as follows. What are the source and heat sink temperature levels for a heat pump from the example with COP of 4.73?
You mean the temperature of the application for the 4.3 for the heat COP?
Temperature of the heat, temperature of the source and heat sink.
So actually, we are kind of about 60 degree of the hot water. That is outlet. Okay, we are kind of about 40 inlet and a 60 outlet for the heat.
Okay, understood.
Okay,
thank you, Alan. You have talked about examples from Finland, from Spain, and from China when it comes to a distribution center, a warehouse, and food processing. Now, are you in discussion regarding projects to be deployed in Southeast Asia using this technology?
Actually, we have some of the potential requirement from South Asia. So actually, the customer is very interested about this technology, and we have some project running to deploy this technology in this domain.
Okay, understood. Now, what do you hear from your customers or from your colleagues on the ground? What are the challenges when it comes to introducing CO2 transcritical in the industrial refrigeration in food cold chain in Southeast Asia?
My understanding for the CO2 application for industry range or application, and I think it's the most challenge is to understand the customer requirement, because if we only count for the cooling requirement, then the CO2 is not, I would say, might not be competitive of comparing within the refrigerant, the HFC or the ammonia. But if we consider the simultaneously the heating and the cooling requirement, for example, if the cold chain had like the food processing, or they have the big amount of the heating requirement, then the CO2 is a good alternative of the our solution. This is the first one, to understand the requirement. And the second one is, so far we know the cost of the CO2, right? And it's so far this is a new thing at some time, right? At some I would say that one. So it's from the Europe and to use South Asia, the cost can be a challenge to the customer, right? This is the second one. The third one is the technology application, because this is new and it's not widely used. So we need some time to explore, to capture the technology in the domain, like for the service, maintenance, installation, something like that one. Yeah.
Indeed. Yourself, you are based in China and you have a strong team in China. Can you maybe give us a short description of what was the story of CO2 Transcritical in China? Because as we know, it has started some 3-4 years ago. And right now we are talking about some 10 systems in retail, and we talk about some maybe under 5 CO2 Transcritical projects on industrial scale. Can you maybe tell us a little bit about how this journey started and about the current trends? Because this might be applicable to the region of Southeast Asia a few years down the line.
Yeah, sure. Yeah, my pleasure. So actually for the application in China, so we know China is the boosting market for all the technologies, and then typical for CO2, actually we started from different applications. From the retail, we started from the C-store, the convenience store for CO2. We have the CO2 CDU for the application. And then we have retail, which is supermarket and hypermarket. We have some case running. And come to bigger, we had food processing. We had a big sport venue, like the ice rink. That is I would say, from the domain, so we are applying the CO2 to the different applications, from the small one to the bigger one. And for the numbers of this application, so we have several players in the market. Okay, we have the several cases, as I just mentioned. We have the case for the C-store, we have the case for the hypermarket, and then we have the case for the food processing. So that is the number is, I would say, so far is it's not like the quite amount of the compared to HFC or ammonia, but the number is increasing slide by slide. I would imagine in the next future years, as the guard KILIC kind of amendment phase out plan taking place, then this number will go up higher, and it goes up and up. Yeah.
Thank you very much. Just maybe 2 more questions. Should there be interest for your technologies and your expertise in Philippines or other parts of Southeast Asia? How is the best? How can the industry best reach out to you or your colleagues? Do you have offices in Southeast Asia? Are you ready to talk about these solutions in let's say places like Manila?
We have the sales office, and we have an application team in Southeast Asia country. So we are based in Thailand and Malaysia. We have the carrier office in this, and based in Singapore. So we have colleagues there. And for the CO2, I think definitely you can reach out to them first if you have the request from the customer. Then also for Asia, we have an CO2 application team, which is we have the training, the service, or the strong kind of technology for CO2. Definitely we will be a background, the backup of the team in Southeast Asia.
Excellent. Thank you, Alan, for sharing all the information and about sharing the case studies, which are always very good examples of how these technologies are deployed. We are aware of the CO2 transcritical systems being running for several years in places like Indonesia, also recently Malaysia, on both retail and industrial. So it will be very interesting to see how these technologies will continue to be introduced in new sectors and in increasingly more countries. So overall, we see a bigger competition between the natural refrigerant solutions, and the winner will be the end user. That's what I believe is the common goal for all the stakeholders. So Alan, thank you very much for joining us today and for your presentation.
Yeah, thank you. Yeah.